Hello students, welcome to the class. In this class, we are going to learn about shadows and their kinds. So let us start by understanding what is a shadow. When I talk about a shadow, you must have seen your shadow on a sunny day, or even when it is starting to get the sun down, you see that your shadow gets elongated. What is this shadow? What is this black color patch that always follows you whenever there is a light source around you? This is nothing but your shadow. A dark patch that is formed behind an opaque body when it is placed in the path of the light is what we call a shadow. It is the reason of absence of light. So ideally, why shadow, that dark color patch is always following you? Because ideally you are coming in between the path of the light. If you are coming in between, you cast a portion behind you on the surface where the light is not reaching. That is, the absence of light is what causes this dark patch to be formed, which we call as the shadow. The sharpness of the shadow depends on the size and the distance of the light. Definitely it will, because how much light you are actually obstructing, it will depend on the size as well as the distance of the light. Now a shadow have two regions of it. Number one is called the umbra region. What is an umbra region? A region of total darkness is called umbra. No ray of light enters in this. That means the complete patch where no light is there, total absence of light, the total obstruction of light happens is called umbra. But you might have sometimes seen that along with your shadow, you see a blurry portion around it, which is called penumbra. What is penumbra? A region of partial darkness which surrounds the umbra is called the penumbra. Some rays of light do reach here, and this region is partially illuminated. Hence, a shadow is a dark patch that is caused by the obstruction of light by an opaque object when an opaque object comes in the path of the light. Why? Because of the absence of light just behind that opaque object. There are two regions of the shadow, umbra and penumbra, right? Now let's just take consideration what are the conditions for the shadow to form. Point number one, there must be a source of light, right? If there is no light, what will be the object be obstructing? Second, the obstruction, that is an opaque object that is going to obstruct the path of the light. And third, there must be an opaque screen to receive the shadow. So if there is no screen behind the opaque object, the shadow will not form. Where the shadow will form, it will form on a screen. So if these three conditions are fulfilled, we see a dark portion following you, that is the shadow. Now, image is formed when light reaches an object, right? But shadow is formed when light does not reach an object, but it is obstructed by an object. So when we talk about does the image and shadow are the same phenomena, the answer is no. Image is formed when light meets at that point on the screen. Shadow is the light is not able to reach at that point, that is absence. Hence these two are not same, right? Let us now understand what the shadow will form if the source of light is point. We did understand that the shadow depends on the source of light as well as its distance from the obstruction. So if the source of light is a point source, that is a needle-like source, what will happen? So in this figure, you can see, let's say S is our source, that is the point source of light, and PQ is the object or the obstruction. It's an opaque body. When the shadow is formed, how it is formed? When the source of light is putting the light on this object, the shadow will be cast on the screen. Where is the screen here? We have a screen just behind our opaque object, right? So here my screen is X, Y, right? So source is S, PQ is the object, opaque object, X, Y is the screen. When the ray starts from point S, travel in the direction of the opaque object. Ideally, I told you that the point source makes the light go in all directions uniformly. But we are only talking about when the light which is falling on the opaque object, what will happen? The ray which travels along SP and the ray which travels along SQ, what is happening? They are reaching at point A and at point B. So the ray which travels SP reaches the screen at point A, and the ray which is traveling through SQ are reaching the screen at point B. Now from the diagram, what we can observe? Number one, the region between A and B on the screen XY. What is it? It is not able to receive any light. No ray of light from the point source is reaching, hence this region is going to have complete absence of light, complete darkness, total darkness, that we call as umbra. The second one, there is no penumbra in this case. There is no partial light that is reaching anywhere near A or B points, hence there is no penumbra. If the screen is moved away from the opaque object, so if we just move XY to the new position X1, Y1, what will happen? The size of the umbra will increase, right? On the other hand, if the screen is moved towards the opaque body, the size of the umbra will decrease. So this is what happens if my source is a point source. What will happen if I take an extended source of light to find the shadow formed by an opaque object? So in this case, we take SS1 as a light source which is extended, right? Now the example could be, it could be an electric bulb, it could be a candle flame or a fluorescent tube light, right? Let's say my opaque object is still P and the screen is XY, so that the source of light is smaller than the opaque. So this is something that we have to note here. What we are taking the source of light to be smaller. So my opaque body is bigger than the source of light that I am taking. In this case, what I am going to observe, students, I am going to see that the rays of light that are starting from point S along SP and SQ meet the screen at B and D. So what is happening? First, just consider S. So along SP, it meets at B. But when it moves along SQ, it meets the screen at D. So we get B and D as 2. What about from the point S1? The S1 point along S1P, it meets the screen at A, and along S1Q, it meets the screen at C, right? What is happening? We see that we, in this case, didn't get 2, rather 4 points. So it is clear that the region which is directly behind the object, which is BC, is the umbra region. Why? Because it does not receive any ray of light either from point S nor from point S1. Hence, this is my umbra. But the region AB, that is this, and the region CD, that is this, we see they receive the light from S and S1. Hence, they are partially lighted up. So, what is region AB and CD in this case? They are my penumbra region. So, penumbra is formed when we have an extended source. For point source, we do not get any penumbra. Now, this was a condition where we were taking the source to be smaller than the opaque object, right? Now, one thing that we can note here, that the size of the umbra is larger than that of penumbra. Can you see? Your umbra is bigger than the penumbra regions. When the screen is moved away from the opaque body, the size of umbra and penumbra both will increase. And if the screen is moved towards the opaque body, the size of umbra and penumbra both will decrease. So what is this? The shadow is giving us information about the shape of the body, but not the information about its size or the details. So when I talk about what is the shadow, you might have seen those shadow games that people use their hands to make different objects. So shadow can give you an idea of the shape, but not the size nor the detail of the object, right? Let's now talk about one last condition where we talk about the formation of shadow when the extended source of light is bigger. So here we take SS1, which is bigger in size than the object, opaque object P. Now what we are going to see, we are again going to see how the shadow is formed. So in this case, the first figure, SS1, the extended source of light, such as I told, you can take a CFL tube. PQ is your object. Now S, the light along P, is going to meet the screen XY at B and at D, and the light from S1 reaching along S1P meets the screen at A and from S1Q at C. right? What we are seeing in this case? We are seeing that the rays of light are forming the umbra and penumbra again, but this time it is a little different from the previous. Why is it so? Because the region BC, which does not receive any light either from source S and neither from source point S1, is the umbra, and the region AB and CD, where we see that they are receiving some light from the point S as well as point S1, they are partially lighted up. Thus, AB and CD are penumbra, right? Now, what you can see here, the answer to the question that does it say similar to the previous one, the answer changes it, because here the size of the umbra, unlikely the previous case, is smaller than the penumbra, right? The penumbra region is bigger. So if the screen is moved backward, then the umbra becomes very small and will eventually disappear. But the penumbra gets larger and at the same time more lighted up. So penumbra becomes so faint that it is hardly visible. In such situations, we do not see any shadow. Now, where can you see such a situation? Have you ever thought that why the birds flying high in the sky do not cast any shadow on the ground? The answer to this is, in this case, which is the extended source of light, is very large as compared to the opaque body. That is the case where we are talking about the previous case. So what happened? The bird is very, very small as compared to the diameter of the sun. So the umbra formed by the bird is so small that it finishes off in the air. We are not getting any umbra at all. But the penumbra formed by it is very large but very faint. Thus, it is hardly visible. Hence, on a whole, we do not see any shadow of the bird flying on the earth. The same happens for aeroplanes that are high in the sky, which do not cast any shadow on the